Hello everyone, this is teacher Mark Anthony Laroya, and this time I will be discussing ellipse. Ellipse is a set of all points in a plane where the sum of whose distances from two fixed points, also known as foci, is constant. Let's say you have the ellipse, and these 2 points, two fixed points, are the foci. If we connect these two lines where the point of intersection is along the ellipse, the sum of their distances will be equal to the sum of the distances between the connection of two lines formed by the same 2 points on the other part along the ellipse. So the sum of these two yellow lines will be the same as the sum of the two blue lines. As well as if we form another two lines where the two will intersect at the point along ellipse, the sum of their distances is also the same as the other two. So let us now talk about the different points along the ellipse. We have the center and the two foci wherein they are aligned along the same path called the major axis. So along the major axis, the two foci and the center of the ellipse are aligned, while perpendicular to our major axis is our minor axis, which also divides our ellipse into two. So this is our minor axis. The points of intersection between our major axis and the ellipse are called the vertices. These 2 points these are the 2 points where our minor axis intersects with the ellipse. Let us now talk about the distances between points. The distance from the center up to one of the vertices of our ellipse is equal to A, while the distance from the center up to a point of intersection of minor axis and the ellipse is equal to B. Now, for the foci, the distance from the center up to one of the foci is equal to C. C can be calculated using the formula C squared equals A squared minus B squared. Simplifying this, we can compute for C, that is C equals the square root of the quantity A squared minus B squared. Let us now talk about the eccentricity of ellipse, or that is eccentricity denoted by E. Eccentricity is simply the ratio of the distance from the center up to one of the foci over the distance from the center up to one of the vertices, or simply eccentricity is equal to C over A. It tells us how elliptical an ellipse is. Let's say we have these 3 ellipses: ellipse number 1, ellipse number 2, and ellipse number 3. The eccentricity of ellipse number 1 is greater than the value of eccentricity of ellipse number 2, as well as the eccentricity of ellipse number 2 is greater than the eccentricity of ellipse number 3. As you notice, ellipse number 1 has the largest value of eccentricity, meaning it is the most elliptical among the 3 figures. Now, this third ellipse, which has the least value of eccentricity, is becoming more circular because the value is getting closer to 0. The eccentricity of circle is 0, while the eccentricity of ellipse can only be between 1 and 0. Let us now talk about ellipse with center at 0, 0. We have two ellipses, the one wherein the major axis is the x-axis and the minor axis is the y-axis. And we also have an ellipse with center at 0, 0, wherein the major axis is the y-axis and the minor axis is the x-axis. The standard equation of our ellipse with center at 0, 0 and the major axis is the x-axis and the minor axis is the y-axis is x squared over a squared plus y squared over b squared equals 1. Always remember that the value of a is always greater than the value of b. Or we can say that in this type of ellipse, the denominator of x squared will always be greater than the denominator of y squared. So since the value of a is the distance from the center up to one of the vertices, that means we're going to move a with a unit or units from the center up to one of the vertices. Let's say for this vertex on the left, that is 0, 0, up to this point, we move horizontally to the left. So that means only the x-coordinate of the center will change. 0 minus the distance of a, that is negative a. So the coordinates of our vertex at the left side will be negative a, 0, or we can call this as our vertex number 1. While our vertex number 2, the vertex at the right side, that is from the center up to this point, the movement is horizontal to the right. So that means we're going to add a units from the x coordinate of our center. So 0 plus a, that is positive a. So our vertex number 2 will have the coordinates a, 0. For the foci, let's say this is our focus number 1 and this is focus number 2. The distance between the center and this focus is c. However, this is from the center moving to the left going to this focus, that is distance c. We subtract c units. So that means from 0, 0, 0 minus c, that is now negative c. So for our focus number 1, focus on the left will be negative c, 0. And for the focus on the right side, so we add c units to the 0 of the x coordinate of our center, we will have f2 or the second focus, that is c, 0. Coming from the center up to one of the points of the intersection between the ellipse and minor axis, the distance is b. So it's either we go up or we go down. So the y coordinate of our center will change. So if we go up, that will be positive b, and if we go down, that will be negative d. So the coordinates of these 2 points are 0, b, and this one is 0, negative b. For ellipse, which has a minor axis, which is the x-axis, and the major axis is the y-axis, and again the center is at 0, 0, the standard equation will be x squared over b squared plus y squared over a squared equals 1. So in this type of ellipse, the denominator of y squared will be greater than the denominator of x squared. So from the center, again, going to the vertices or going to one of the vertices, the distance is a. Since we move vertically upward and downward, that means the y coordinate of our center will change. So from 0, 0, going to this upper vertex, or that is V1, this will now be equal to, the coordinates of our V1 will be 0, A. And this lower vertex, or V2, will be 0, negative A. So we add A units and we subtract A units. For the foci, same concept as the vertices. For this focus number 1, the upper focus, we add C units to the y coordinate of our center. So this focus now will have the coordinates 0, C. And for this lower focus, or the focus number 2, will have the coordinates 0, negative C. For the 2 points of intersection of our minor axis and the ellipse, the movement is horizontal. So it is the x-axis, or x-coordinate of our center will change by adding and subtracting b units. So going to the left, we subtract b, and going to the right, we add b to the x-coordinate of our center. So the coordinates now of these 2 points will be negative b0 and b0. Let us now solve some problems involving ellipse with center at 0, 0. What are the coordinates of the foci of the ellipse with a standard equation of x squared over 25 plus y squared over 9 plus 1? By looking at our standard equation, we can see that the denominator of x squared is greater than the denominator of y squared. So we can say that the major axis of our ellipse will be the x-axis. And that's so, our a squared is equal to 25. And getting the square root of 25, our a now is equal to 5. Our b squared is 9, and so our b will be equal to 3. By using the formula in getting the value of c, c is therefore equal to the square root of 25 minus 9, or a squared minus b squared. So that is square root of 16, or simply c is equal to 4. And again, as I've said earlier, the major axis of our ellipse is the horizontal axis. So this is our ellipse with center at 0, 0. The distance between the center and the focus is 4 units. So if we're going to identify the coordinates of our focus on the left side, we subtract 4 units to the x-coordinate of our center. So 0 minus 4, that is negative 4. So our focus on the left side will be negative 4, 0. And on the right side now, we add 4 units because that is going to the right. This will now become 4, 0. Let us now determine the standard equation of the ellipse. So given the figure of our ellipse, as you can see, it is a standing ellipse, or the major axis is the y-axis and the minor axis is the x-axis. As you notice, the distance from the vertex to the center is equal to 6 units. That means our A is equal to 6. And the 2 points of intersection of our minor axis and the ellipse, the distance from the center up to one of these 2 points is 3 units. That means our B will be equal to 3. So simply plugging in the values using the standard equation of ellipse with major axis of y-axis as the major axis, we have x squared over b squared plus y squared over a squared equals 1. So b squared will be 9 and a squared will be 36. So the standard equation now will be x squared over 9 plus y squared over 36 equals 1. Thank you very much. I hope you learned something new about conic sections, especially ellipse, with center at 0, 0. See you again next time.